Our utility grid is evolving. Consumers, businesses, and institutions are embracing solar, electric vehicles, microgrids, and other distributed energy resources. These DERs are beginning to change the nature of our power grid. These systems are built and managed by a wide variety of contractors, vendors, and service providers, and by definition, are distributed across large geographic areas. Utilities, transmission operators, and balancing authorities need to understand the impact of DERs on the grid. They need a way to use them collectively to help manage grid reliability and to participate in the ancillary services markets at ISOs. With the right technology, stakeholders can gain visibility into the operation of DERs, with tools that let them visualize, contextualize, and analyze these increasingly important resources, and ultimately, to take advantage of them as a powerful collective asset. It's possible with a collaborative software solution from OSIsoft, Esri, and SAS, integrated with hardware based on Qualcomm technology. The Pi system infrastructure makes it possible to bring together data from any source, including traditional grid assets, SAS predictions, and data collected by intelligent Qualcomm gateways from DERs located behind the meter. This ArcGIS map exposes all of this real-time Pi system data for traditional grid assets and distributed resources, like the generation of this rooftop solar system. Pop-ups for each map feature show the relevant real-time and contextual data for that asset. In this case, the status, demand, and storage capacity of this electric vehicle. Heat map layers take advantage of Esri's powerful built-in data visualization. Analytic models from SAS drive the data behind this layer, showing the power these electric vehicles are capable of generating in a vehicle-to-grid scenario. This time-lapse shows how the dispatch capability of these vehicles roams between residential and commercial areas. Another layer shows the intensity of solar output. This time-lapse shows the changing solar generation throughout the day. Grid operators can zero in on concentrated areas of solar and the grid assets that could be affected, like this distribution transformer. For a deeper understanding, PiCoreSight and SAS Visual Analytics are one click away, providing trended sensor data and analytics for the selected asset. PiCoreSight provides pre-configured displays for every asset type, giving you the most critical information immediately. The owner of this resource now has detailed data at their fingertips to assess the current and predicted impact of DERs. SAS brings additional visualization and predictive analysis capabilities. In SAS Visual Analytics, views of collective asset performance quickly summarize large datasets to drive decision-making. SAS data mining is used behind the scenes to test, train, and validate predictive models. This analysis of transformer dissolved gas tested multiple predictive techniques and found that a neural network model predicted transformer failure most accurately. The best model is selected automatically, and once in production, PiCoreSight support for future data means the predictions generated by SAS can be viewed alongside historical and real-time asset data. Because of the growing number of DERs, the solution requires the management of significant quantities of sensor-based data. Even by conservative estimates, for a large California utility, current installations alone would require millions of data streams. OSIsoft's advanced data infrastructure provides the means to collect and manage all of this data efficiently and to scale to accommodate the growing number of DERs. Through its partnership with Qualcomm, OSIsoft's infrastructure natively connects to this massive source of industrial digital data using Qualcomm-powered hardware. These intelligent Qualcomm devices provide an integrated communications and computation platform and are capable of bidirectionally communicating with DERs like solar inverters and electric vehicle chargers. Using embedded Pi connector software, this data is transferred securely from Qualcomm-powered devices to the Pi system. And because most utilities and ISOs are already using OSIsoft's data infrastructure, it's possible to combine data from DERs with other existing time series data from utility SCADA, EMS, and DMS systems. The Pi system can even handle high-speed data from PMUs. The OSIsoft infrastructure also contextualizes this time series data to seamlessly drive aggregation and summarization at any level in the grid topology, which is essential to making sense of the data. A native bidirectional integration through the SAS Access interface to the Pi system allows efficient sharing of key data streams for analytics. In the SAS platform, powerful algorithms are applied to understand relationships in the data, generate forecasts, and develop load, demand response, and failure models. These models can be run in real time and their results fed back into the Pi system. Through OSIsoft's integrator for Esri, features with real-time data are shared with the Esri platform. Esri's ArcGIS brings all of this time series and contextual data into one powerful situational awareness view, accessible through thin clients and mobile devices. And with direct links to Pi CoreSight and SAS Visual Analytics, drilling into Pi system data and SAS analytics from Esri Maps is simple. Solving the challenges that utilities, ISOs, and municipalities face when it comes to distributed energy resources is no easy task. OSIsoft, Esri, SAS, and Qualcomm are trusted leaders in their fields. Bringing these providers together into one powerful package represents a new paradigm in data visibility, situational awareness, and analytics for distributed energy resources.